Hey guys, it's Chris at Highline Guitars. You're watching another one of my YouTube guitar building videos. If you're new to my channel, welcome. I hope that by the end of this video, I'll have earned your subscription. Okay, so what I'm going to be talking about today is I'm going to be showing you how I create a full-size, full-scale 3D model of a fretboard for a guitar. And specifically, this is going to be a multi-scale fretboard that will have a compound radius. And this is all part of my 6-string multi-scale guitar building project. So today's video, I'm going to feature the fretboard, and then in future video, I'll do the neck, and then I'll do the body. And I'm going to try to incorporate as much detail as I possibly can to explain how I generate these models, because a lot of folks seem to be interested in that. They want to know how I do this so that they can do it themselves as part of their CNC guitar building process. So the first thing I'm going to do is I'm going to show you the finished components here for this. And what I have is this is the 3D model that I'm going to be creating. This is the finished model. I want to show you what it looks like when it's complete so you have an idea of where this is headed. And as you can see, it's a multi-scale fan fretboard. And you can tell because the slots are at those weird angles that you get when you do a multi-scale fretboard. And for this particular design, the scale lengths are, for the low E, it is 28 inches. For the high E, it's 25 inches. And then for the fretboard radius, I'm doing the compound radius, and at the heel, it's 16 inches. And then at the nut, it's 10 inches. So I'll be creating that with this file. And that's what I'll be using for the fretboard on this 6-string multi-scale fan fret guitar build that I'm currently working on. So to get to this point, what I have to do is I need to create a template, so to speak. And this is a 2-dimensional template. What you see here was created in Adobe Illustrator. And I use Adobe Illustrator because I've used the program for many, many years. And it's very accurate. I mean, it's plenty accurate for what we're doing as far as guitar builds are concerned. Plus, I use these files for a lot of other purposes, not just guitar plans, but also for mock-ups and other illustrative purposes. And when I do these, I do them full size and full scale, and I use them as templates to build the 3D model, which is done in Rhinoceros. The current version of Adobe Illustrator, the very latest version that has just come out in the last week or two, has dimensioning capabilities, much like you would find in a traditional CAD program. So Adobe Illustrator is sort of becoming an illustration / CAD program. So I can use it for both. And I created this file in Adobe Illustrator, and I'll use this, like I said, to build the 3D model. Now, to get to this point, what I have to do is create a template to build this template from. So I'm using a template to create a template. And I'm doing that in it's an online program called FretFind 2D. And I've talked about this program before, this website. For me, it's indispensable. This is an incredible tool for laying out your fretboards. And you have a lot of options and a lot of possibilities. It's very full-featured and pretty easy to use. So I'll kind of walk you through how I set up the file. I work in inches. It's because I'm here in the United States, and the vast majority of the people watching my videos are here in the United States, so I stick with inches. But you can also do centimeters and millimeters. The display, you can show the fretboard edges, which I have checked. Show the strings, which I also have checked. You can extend the frets to the edge, and what that means is you can select a bounding box, and that draws a bounding box for this whole image here. And then you can extend the frets to the edge of that. I leave those two options off. I don't need them. You can also show metas, and what that is lines that are between the strings. And typically I don't show those. If you're going to be laying out fret markers, you might want to consider leaving those meta lines in there, but I typically don't use them, so I switch them off. Now for scale length, I can do a single scale length, which is, you know, your traditional guitar, like a 25.5 inch scale would be for a Stratocaster, 24 3/4 would be for a Gibson Les Paul type scale. Or you can do multi-scale, which is what I'm going to be doing, and you can even do individual scales, a different scale for each string if you really want to get experimental here. I don't mess with this, and it says danger experimental, so I don't really mess with that. I haven't, or at least I haven't messed with it yet. Who knows, down the road I might. I can think of some possibilities there. Anyways, I'm going to be using the multi-scale, and for the first string, which is the high E, is going to be 25 inches, and that's the default number that comes up, so I'll just leave that. For the last string, which is the low E string, I'm going to do that as 27 inches. And then for the perpendicular fret distance, what that is, the perpendicular fret is the vertical, or in this case, the horizontal fret, because we're looking at the fretboard vertically. So the horizontal would be the perfectly level fret. And in this case, it's the 12th fret. So you type in 0.5, which is going to be the middle fret. Since this fretboard is going to have 24 frets, it's going to make the 12th fret the level, horizontally level fret. But if you click on the question mark in that gray box down there, you can see the numbers that you would input if you want to change that perpendicular fret. So like, you know, I've got a half 0.5 selected, but if I wanted to do if I wanted to do the 9th fret as the perpendicular fret, I would type in 0.40540. And, you know, any of these other ones. And, you know, that's something you would do if you were experimenting with making a different fret, the perpendicular fret. But 12 is pretty common. 9 is also common, but I'm going to stick with 12, so I'll leave that as 0.5. String width at the nut. The default that comes up is 1.375 inches, or 1 3/8 inches. This is totally up to you. It's whatever you want that string spread to be at the nut. Now, we're not talking about the width of the neck. We're talking about the center of the high E to the center of the low E string. And I'm just going to stick with the 1.375 inches. That's a good, common, popular measurement. Now, for the string width at the bridge, this is a little bit different. If you're doing like a Stratocaster or a Telecaster where you're using a bridge that has a fixed string width, you would want to measure between the high E and the low E, the center to center dimension, to get that string spread at the bridge. In this case, because this is a multi-scale fan fret neck, I'm going to be using individual solo bridges. So I've already determined when I laid out the design in Illustrator for the guitar, and we can go back here and I can show you that. I've already determined how I'm going to position those bridges here. So what I did was I measured the distance between each string. And in this case, that dimension that I get from one string to the next is going to be 0.4385 inches. So if I multiply that by 5, I'll get my calculator here, 0.4385 inches times 5 is 2.1925 inches. So that's the string spread for this particular guitar. So I got to change this to 2.1925, and that's going to be the actual string spread. Now, if I want the string spacing to be equal, which is what I typically do, I'll just select equal, but you can also do proportional. And when you do proportional, what you have to do is input the gauges of the strings in inches. Or if you're doing millimeters, you would do millimeters. But since I'm in inches, I would type in, for example, 0.010 for the high E, and then maybe 0.013 for the B string, and then 0.017 for the G, 0.026 for D, 0.036 for A, and then 0.046 for the low E. And what that's going to do is it's going to position the strings so that the distance between the strings is equal as measured from the actual physical edge of the string rather than from the center line. So you can do that and get a really accurate layout. Or you can just leave it equal and not worry about it. I'm going to leave it equal. I find that it's really not that big of a deal. But if you want to get super, rocket to Mars precise, then you could do that. You could do the proportional. But of course, you're going to have to know exactly what gauge strings you're going to be using on the guitar when it's finished. Fretboard overhang, that's the distance between the center of the high E and the low E strings and the edges of the fretboard. And the default that comes up is this 0.09375. I like to do 0.125, an eighth of an inch. Now you can also do nut to bridge, which you can change the distance, obviously, between the edge of the string and the edge of the fretboard at the nut than what it would be at the heel. And you can do that when you do nut to bridge, that would be on both the high E and the low E string. Or you can do first to last. So you could actually make the string close to the edge of the fretboard at the nut and further away from the edge at the heel, or vice versa. And then you can do all, which allows you to set the dimension, the distance at the nut and at the heel differently. And you can do it differently for the high E than you would for the low E, and vice versa. So you've got a lot of options there. I'm just going to keep it equal, keep it simple. I don't need to do that for this build. You know, if I had a customer who specified that they wanted it that way, I could do it that way, but I'm not going to actually do it that way. Number of frets. What comes up here, the default is 24. Now I'm going to have 24 frets on this neck, but what I'm actually going to do is I'm going to type 25. And what that does is it creates a fret, an extra fret. But what that extra fret really is the end of the fretboard. So I know where it's going to be laid out to. And of course, I'm doing the number of strings is 6. And then tuning. This is something you really only need to worry about if you're doing the calculation method differently. Now I'm using just the equal calculation. That's the standard way of doing the scale length calculations here. But you can also do this other feature, this Scala, I believe it's pronounced. And this will give you a much more accurate layout of the fretboard based on this Scala STL file. But I haven't really messed with this. I'm not really sure exactly how it works. So that's something you would have to explore on your own. But they have a link to a web page that I guess will tell you what that is. But you don't need to worry about the tuning unless you're doing that Scala length. So, and I'm not, like I said, I'm not going to do that. So once I've done this, I can then download this as a PDF file. And I have all these different options here. I can do an SVG file. I can even do a CSV, like a spreadsheet. But I'm just going to use the single page PDF file, and I'll click that and save it to my hard drive. Now I've already done that, so we're going to jump back in to Adobe Illustrator, and I'll show you how I lay out this fretboard. Now, even though I can open the PDF file that I just created in Adobe Illustrator, I have to redraw the file because all of the lines are separate small segments. They're not all connected as one or a series of shapes. They're all little individual lines, and I can't use that file to create the 3D file. I mean, I could link together the lines, but it takes a great deal of time to do that. So instead, I'm just going to redraw it. And to do that, I'm going to use what are known as guides. I'm just going to drag a guide right off the ruler over to the drawing. And you can see that as this sort of teal blue colored line. I hope that shows up in the video. But I will unlock the guides so that I can select it, and then what I can do is I can rotate them, and then I can rotate the guide so that it is following the perimeter shape. So I'll do a line like that, and then I'll do another one like this and drag it down like so. And then I'll drag another one over here and rotate it like so. Then I'll do one at the very end of the fretboard. Rotate that like so. Now what I have to do is I have to drag the guides for the frets. Okay, so I've got all the guides in place, but I still need to add 2 more guides. And what those guides are going to do is indicate where each fret slot starts and where it finishes. Because since I'm making this fretboard on a CNC machine, I'll be cutting the slots with my CNC machine. I'll be using an end mill. And because of that, I can stop short of the edge of the fretboard, thus creating what some folks like to call a blind fret slot. However, that's really not an accurate term because fret slots can't see, so they can't be blind. It's a hidden fret slot or a concealed fret slot. It's almost like when you bind a fretboard and you cover up the slots on the sides of the fretboard. So what I'll do is I'm going to select the template drawing, and then I'm just going to hit Command 3 and hide it. So all you see now are those guides. And I'll zoom in here a little bit. Hopefully you can see this. And what I'm going to do is I'm going to select one of those guides. And when I select it, it turns that dark blue color. Then I'm going to hit Command K, which brings up my preferences. And up here at the top where it says keyboard increment, I'm going to type in 0.09 inches. That's where I want the slot to stop, from the end of the slot to the edge of the fretboard. So I'll hit OK. Then I'm going to hold down the Option key and hit my right arrow, and that creates a duplicate and moves it 0.09 inches in. So then I'll grab the other line on the other side, hold down Option and click the left arrow. Now I have my guides for where I want those fret slots to end relative to the edge of the fretboard. What I can do now is I can draw the perimeter. So I'll come up here and I'll zoom in, and I'm going to use my pen tool, and I will click where those lines intersect. Then I'll zoom way out, and I'm going to come all the way down here and click on that corner. Then I'll click on that corner. Then I'll go all the way back up to the top. Click at this corner, and then I will close it. So now I have my perimeter shape, and I'll give it a stroke of about 0.0156 inches. So now you can see the perimeter shape of the fretboard. So now what I'm going to do is I'm going to grab my pen tool again, zoom in, and I'm just going to start to draw my frets, and I'm using those inner guides as where it's going to start and end. So there's the first fret. When I draw this, I left click to start it, left click to end it, then I pull off here just anywhere arbitrarily, left click again, and then delete that. And I'll just keep doing this all the way down, drawing all of the frets. And now once I have the frets drawn in, I don't need any of the guides anymore. So I'm going to go to Guides and Clear Guides. And there is the basic drawing of the fretboard and the fret slots. But this document size is incorrect because this was the document size that was created for that PDF file when I saved it out of the Fret Finder 2D website. So what I'm going to do is I'm going to select all those elements, the perimeter shape and all the frets, and then I'm just going to do Command C to copy it. Then I'm going to go into the document I created earlier, which is the actual blank size, 3.5 inches wide, 24 inches tall. And when I fit it into the window and then paste, it centers it perfectly in that space. And whenever I'm building 3D models using these type of templates from Illustrator, I like to make sure that they are always centered in the document size, which is the blank size that I'll be cutting from. And the reason for that is some of the parts that I'll be cutting are going to be two-sided carving operations. And I want to make sure that they're centered in the blank so that when I flip the blank on the CNC machine, everything registers and lines up. I hope that makes sense. Once you've done this a few times, it all starts to click. All right, so now what I need to do is I need to turn those lines that I drew for the fret slots into boxes because they're lines right now. And even though I could use that in preparing my CNC files, it's better as far as getting an accurate model to create a pocket, because that's what a fret slot is. It's basically a pocket. So what I'm going to do is I'm going to select all of the slots, and then I'm going to change the width of the stroke, the thickness, to the same thickness that I would want the slot to be, or the same width that I want the slot, which in this case is 0.023 inches, which is typically what the dimension of a fret slot. That's what you want it to be in order to capture the tang of the fret and the barbs firmly. So I'll type in 0.023, and that's how thick each of these lines that I drew for the fret slots are now. So what I'll do is I'll go up to Object, down to Path, and then Outline Stroke. So now they're boxes, but they're filled with black, which I don't want. So I'm going to fill it with nothing, and then I'll fill the stroke black. So if you zoom in, you can see they're boxes. And that's what we want to get that correct fret shape. Now what I have to do is I need to create a template for the radius. Now remember, this is a compound radius fretboard. So I need a radius at the heel of 16 inches and then a radius at the nut of 20 inches. So what I'm going to do is I'm going to draw a circle using the ellipses tool, and I'm going to do 2 circles. Now Illustrator is drawing the circles based on the diameter, not the radius. Well, if it's a 16-inch radius, that's going to be a 32-inch diameter circle. So I will make it a 32-inch diameter circle, which is what I have right here on this side. I'll kind of zoom out so you can sort of see it. It's that big blue circle. Now I'm going to do another one on the other side, And this is going to be 10 inches, a 10-inch radius. So that means for a diameter, it needs to be 20 inches. And that's going to be the radius at the nut. Now what I have to do is I have to draw a rectangular box that is an indication of the end of my fretboard blank, which I happen to have a fretboard blank here. This is a nice piece of Padook. So I'm drawing a rectangle to represent this edge. So in this case, we already know from the size of the box that or the document that I created, that it's going to be 3.5 inches wide. And I think for my fretboard height, I'm going to do 1/4 inch. So we will do 3.5, 2.5, and then what I'm going to do is I'm going to select the center, move it all the way up to the top and to the center of the circle. But then what I want to do is I want to move it down so that the top of this rectangle is flush with the very top of the circle. So I will move it down until it snaps into place. So now what I need to do is I'm going to get rid of the upper right and upper left corner, so that it's sort of like creating a radius template. And I do that by clicking the Pathfinder option. And then what I end up with is this shape here. What I will do now is I'm going to bring this down, place it into the document. And what I want to do is I want the bottom edge to line up with the lower corner of the fretboard. That way it's centered. It will be centered. Okay. And I know this is probably not making a lot of sense now, but it will here shortly. Trust me. So now I'll do the same over here for this side. But this time, instead of moving it to the top, I'm going to move it down to the bottom. And then move the rectangle up. Then I will come over here to Pathfinder and I will click this option. And then I end up with that shape there. And then what I'm going to do is I'm going to move this up to the top of my fretboard drawing. And I'm going to bring that edge down until it's flush with that corner, upper corner of the fretboard at the nut end. Now the reason I'm doing that is because I want to keep all this stuff centered in the document. I don't want anything to be off. So that's why I've laid it out like this. Now there's one other thing I need to do, and that is to indicate the bottom of the fret slots on this template, because the bottom of the fret slot is going to be radiused. Now I typically don't radius my fret slots. And I'll probably talk more about this as I'm actually making the fretboard later on, but I know a lot of folks like to radius their fret slots. So I'm going to build this model to include a fret slot that has a radiused bottom to it. That way you have that option to create the radiused fret slot if you so choose. To make the radius slot, we're going to have to do a little bit of math. And we know that at the heel, the radius is going to be 16 inches, the fretboard radius. So I'll grab my calculator. And what I need to do is subtract the depth of the tang that will be pressed into that fret slot. Now I've measured the tang on the fret wire that I'm going to use, and it has a depth of 0.07 inches. So I'll subtract that from the 16-inch radius. And what I get is 15.93. So to draw a circle in Illustrator, I need to multiply that by 2 to get the diameter, which is 31.86 inches. That's for the heel. So I will draw a circle, And I've already got the numbers in, 31.86. So I will draw that circle, and there it is. Pretty big circle there. Now what I have to do is, once again, I need to draw that rectangle. So I'll just come up here close to the top, and those numbers 3.5 and 0.25 are from what I did previously when I drew the box, and those numbers stay there so I don't have to retype them in. So I will go ahead and draw that box. And then what I'm going to do is I'm going to move that box up to the top until it is flush, so that the top is flush with the top of the circle. And then I will use my Pathfinder option over here on the far right of the screen, and I will click that, and we get that nice shape. But I do not need the corners anymore. I just need that curve at the top. So I'm going to delete those. Then what I'm going to do is I am going to drag this down, and it is now placed right over the top. But it needs to be moved down to represent the depth of the slot, which of course is 0.07 inches. So I will knock that down, and we now have an indication of the bottom of the slots with the 16-inch radius, or it's actually 15.93 because we have to subtract that depth of the tank. Now I have to do the same thing at the top, at the other end, since this is a compound radius. So what I have to do is draw another circle, but we have to figure out what that dimension is going to be. So I'll grab my calculator. Radius is 10 inches, so we know that the diameter is 20 inches, so we'll type in 10 for that radius. Then we're going to subtract 0.07, and that gives us 9.93. Now to get the diameter, we multiply that by 2, and we get 19.86 inches. So I will draw a circle over here that is 19.86. And that is the radius of the bottom of the fret slot at the nut end. So again, I have to draw the box. Then I will select both, hit that Pathfinder option. We have that circle. Then I can delete the corners, so that I have just that radius. And then I will move this up to the top so that it is right on top of that radius. And then I will move it up 0.07 so that becomes the bottom. Now I know a lot of this may not be making a whole lot of sense right now, but as I start to build the 3D model, you're going to understand. You'll see how this is all working. So at this stage, I have everything that I need done for this 3D model. So what I'm going to do is I'm going to save this as an Adobe Illustrator native file to my computer hard drive. Then I'm going to go into Rhino to start building the 3D model, which is what I'm about to do right now. Okay, so I'm in Rhino right now, and I'm using Rhino 7 for the Macintosh. A couple of weeks ago, Rhino 8 came out, but I haven't had a chance to upgrade yet. However, I don't think any of the commands and techniques that I'm going to use in these videos is going to change all that much, so it should work just fine. So what I'm going to do is I'm going to create a new document, and what you see are the 4 different views. You've got perspective, top view, front view, and right view. I typically will do most of my work in perspective, which is this view right here. And what I'm going to do is I'm going to import my 6-string fan fret fretboard. So, and it's titled 6-string fan fretboard. So I will import that, and it will come in to Rhino as a 2D flat drawing. And what I have to do is I have to rotate these elements for the radius. I have to rotate those 90 degrees in order to use them because right now they're laying down flat. So to do that, I select them, and I'll select the ones at the heel first. And I'll go into my right viewport and I'll zoom in to where I see this yellow line running across here. I'll grab the Rotate 2D tool, and then I will click all the way at the far left of that yellow line. And I will left click once and I will drag out, and you get this circle with a black line. And I just drag that to the other end, left click again, and I hold down the Shift key and I rotate, and that automatically flips it up 90 degrees. So when I go back into perspective, you can see now it has been rotated up. Now I have to do the same to the other side. However, I have to do it a little bit differently since the radius curvature is facing inward in the opposite direction. So I will grab my Rotate 2D, but instead of clicking on the left side, I'll click on the right side. And I'll left click, drag that out, or I'll just move the mouse. When I do the left click, I left click once, let go, and then I move the mouse out. And then I will click at the other end, I'll left click, let go of the mouse button, and then hold the Shift key down, and it will flip it up 90 degrees, just like that. So when we go in the perspective, you can see it's been rotated. Now I don't need the line, the straight line that runs at the bottom, or that very tiny one that runs up the side. Those are extraneous, I don't need them. So I'm going to select that, because it's all grouped together. I'm going to select that line. Then I'm going to go up to the far left menu. You see the explode option. I'll click that once, and that breaks all those lines apart. So I can select the bottom line and delete. And I'll select that tiny line on the side and delete that. Now I've got just these two lines. The top one represents the radius of the fretboard surface. The bottom one represents the radius of the bottom of the fret slots. So then I will go back out and I will do the same at the heel end. I'll select that element. I will break it apart with the explode button. Then I will select that bottom line, delete it, select the other line, delete that, and that leaves just those two curves. Now the thing is, this top line is actually in two sections, and I need them to be in one. So I will select one, just like this, and then I'll hold the Shift key down and select the other one. Then I press the J on the keyboard and return, and that connects them together. Do the same thing at the other end. Select that half of the line, Shift, and select the other half of that line. Press J and hit return. They're now linked together. The other lines, because of the way they were drawn, are still just one. So then what I'm going to do is I'm going to zoom in, and I need to connect that lower line at the heel with the lower line at the nut. And I do that by drawing a polyline from this end. And I will left click once. Then I will move my mouse up to this end. And when it snaps to the end of that curve, I'll click left again and then right click once. Then I will do the same. What I just did was I clicked left, right mouse button, and that brings up this menu options, and I'll click repeat polyline, and I'll come over here and I'll click left once and then move to the other end until it snaps to that end, and then I will left click once, right click once. Then I can select that curve, these two lines, and then the other curve at the other end, the lower radius curve. With those two clicked, I can go up here to the top, and I've got all these menu options that run along the top. And I'm going to just click it once. Then I'm going to come over here and I'm going to select network surface from network of curves. And that creates my curvature. Okay, now what I need to do, because this curvature is the bottom of the fret slots, the radiused bottom. So what I'm going to do is I'm going to go back up to the top view, and I will go out here and click and hold while I drag down to select just those slots. those rectangles that form the slots. Go back to perspective view, and as you can see, they're below that radius of curvature. But what I'm going to do now is I'm going to take my surface extrude command straight, and I'm going to extrude it well above that radius curvature, and then I will left click once. And now I have created the slots, the pockets, but as you can see, they extend well above the radius surface. Now those yellow lines are the paths that I had created, that I imported in. They're still selected. I don't need them anymore, so I can just hit delete, and now they're gone. So what I'm going to do now is I'm going to go back into top view. I'm going to select those extruded slots, and I'm going to use those to trim away the excess radius, because I don't need the radius out here. So what I'll do is I will select them all. Then I'm going to come up here to the menu on the left side, and I'm going to click the trim tool. Then all I have to do is just move my mouse out here over that radius, and then just left click once and it deletes it. But it still leaves the portion of the radius inside each slot at the bottom. So that's what's going to form the bottom. So now what I need to do is I need to delete this excess portion at the bottom of the slot, because it's not necessary anymore. So I'm going to first click done. Then what I'm going to do is go to my right view. And you can see those curves. Those curves are that radius surface at the bottom of the slot. So what I'm going to do is I'm going to click out here and drag and just select that part, those components right there. That's all I need, because I'm going to use that to trim away the bottom of those slots that I don't need anymore. So I'll come back up here to the left side menu, click the trim tool. Then I'm going to go down at the bottom of each slot and trim away that part of the tool, or that part of the fret slot. Okay, and I've got to do this individually with each slot all the way along the length. And what I end up with is a slot, a fret slot for each fret that is radiused at the bottom. However, it's still too tall. As you can see, it goes way up in the air. There's no fret tang that's that deep. So what I need to do is, once I have trimmed away the bottom, is click done over here. Then what I'm going to do, I can get rid of the elements, the path elements that I used to form the bottom of that slot. And that leaves just the curve for the top part. So I'm going to select my polyline tool again. I'm going to bring it down here. I'm going to left click once, bring it up to that end, left click once, right click. And then I'll do it the same thing on the other side. So I'll right click and then select repeat polyline, left click, right click. Then I can select that curve and these two lines that I just drew and that curve. Then I'll come up here to the left menu and select surface from network of curves. And there we have the top surface of the fretboard. And once again, the yellow line is the path that's still selected. I don't need it, so I'll hit delete. Then I'm going to select that radiused surface. I'm going to come up here to the left menu, grab my trim tool. I'll zoom in a little bit so I can see what I'm doing. And then I'm just going to trim away the parts that I don't need. And it's trimming it right down flush with that compound radiused surface. Pretty quick and easy. But the slot is filled in by that surface. So we have to change that. And to do that, I'm going to click done here because I just finished my trimming. And then I'm going to deselect. I'll go back to the top view again. And then I'm going to select just those extruded fret slots. And then I'll go back to my perspective view. And this is where it gets kind of difficult because we're dealing with such a tiny little area. But when you zoom in, you can see how the slots are formed. So I've got them selected. So I'll grab my trim tool up here on the left menu again. And then I go into the middle of the fret slot between its edges, its sides. And I click once, and that will delete the top part of that radius, exposing the fret slot. You may be able to see it better when I do this one. And as I move over, you can see that it's now created a slot. It's a bit difficult to see, I admit, but I'll just move along to each fret, just like this, clicking that center part of the top until I have opened up all those fret slots from one end to the other. And you can see how the slots are changing the angle as we get towards the nut. And it does take a little bit of experience to do this. You may have to do it a couple of times before you figure out how it works. But what I've just done now is I have opened up those fret slots. So when I click out here, well, first I have to hit done. But when I click out here, there's the slots. They are now drilled in or cut into the surface of that radius, and the bottom has a radiused surface. So what I can do now is I can select the perimeter shape, which it's probably easier to see it when you're in the top view. I've just selected that, so I'll go back to perspective. Now it's open right now and I need it closed off, so what I'll do is I'll come up here to the left menu and I'll select surface from planar curves, the second option down, and that fills that surface. Now the yellow line indicates that the paths are still connected, and at this stage we want to continue to keep that selected, because what I'm going to do now is I'm going to extrude that as a surface straight up. So I'll pull that up, and you can go as high as you want, but I'm going to try and get it just above the height of the fretboard. So once I've done that, that yellow line means the path is still selected, and at this stage I don't need it anymore, so I'll hit delete. Then what I'm going to do is I'm going to select that, and I'm going to use that to trim away the excess surface. So I'll come up here to the left menu and I'll grab that trim tool, and I will just click in that area on both sides, and that deletes that excess surface. And I'll click done. Then I'll select the surface and use that to trim away the excess side. And it's gone. And there we have a finished fretboard for a 6-string multi-scale fan fret guitar with a 16 to 10 inch compound radius. So from here, I can save this out as a Rhino file, which I will do. I'll save it as the native file format. Then, well, here, I'll just do it. We'll save this, and I've actually already saved it before, so I would give it a name up here, and then I would hit the save button, but I'm going to hit cancel because I don't want to save this over what I've already done. What I'm going to do, however, is show you how I export this as an STL. So you have all these different options that you can choose from to save, but I like to use STL because it's pretty universal when it comes to building 3D models and for doing tool path, selecting and programming your tool paths for G-code and CNC. So I would just the name, once I've named this, when I saved it as a native format, it'll come up here and it would automatically be named, and I'm not going to worry about that now. But I'll just save this to my desktop, just as an example. You can save it anywhere on your computer you want to. I would save it as an STL, and then I would hit export. And then for the tolerance, I would do 0.001. And that's in millimeters. And then I would click OK. And I leave it the binary option. 366 kilobytes is fine. The reason I do the binary option is because when you start doing more complex shapes, like for the neck and for the body itself, these files can get fairly large, and binary tends to be smaller. And I can't tell the difference in quality between a STL file that's been saved as binary or ASCII, but it is smaller in size. So then I would just export it, and that's it. That's how I build these 3D models and how I export them as STL files.